Hello, I'm Dora Blanco. I'm full professor at the University of Santiago de Compostela and senior researcher at CITIUS, also here at the University of Santiago. This podcast is on the School of High Performance and Disruptive Computing in Remote Sensing that has been held here at CITIUS during the first week of June 2024. This school has been organized by the Earth Science Informatics Committee of the IEEE GRSS Society. 35 students of all around the world has been selected to attend this school. This has been supported by different institutions, universities, and other companies. For example, IBM, NASA, ESA, Google Earth, the University of Iceland, the University of BOKU, and other institutions, including, of course, the University of Santiago de Compostela, and in particular, CITIUS. The objective of the course is to provide to the students knowledge on the recent advancements, basically on high-performance computing, machine learning, and quantum computing applied to remote sensing. The role of high-performance computing in remote sensing has been one of the most relevant topics of the school. We had here two Google developed experts presenting Google Earth Engine, and they are here to talk with us. The first one is Emma Izquierdo. This Dr. Emma Izquierdo is a Google developed expert and is postdoc at the University of BOKU in Vienna. Dr. Álvaro Moreno is also postdoc at the University of Valencia. I hope that you enjoy this conversation. Welcome, Emma and Álvaro, to this conversation. It's a pleasure to share this time with you both. Hello. Hi.
Hello. Thank you for the invitation.
We need to explain to our audience, first of all, what is a Google developer expert, because the name sounds very big, but we don't know what exactly a Google developer expert. Could you explain us?
What's a Google developer expert? Do you want to start or?
Yeah, I can. Yeah, no problem.
She started being a Google developer expert before than me.
So, Google Developer Expert is a program that Google developed in order to recognize expert people in specific applications of the different technologies that the company has. And in that case, Earth Engine application was our as a Google Developer Expert category in 2022. And in that case, it's a program which consists on yearly hour, these people that has specific knowledge and high level of knowledge of the different applications. And then the company recognize the knowledge and recognize the effort and the timing that we use in order to learn the different application. I don't know if you would like to add something more.
Yeah, I mean, it's basically a recognition, because I think that at least we know each other for a long time, and I think it was something that we didn't force so much. It was about being enthusiastic and using the platform, because it was something that we used for something that maybe we will talk later, but it was so useful that we just learn and we teach, taught about it. So, and that's basically probably the reason why they consider or they give us the opportunity to be Google developer experts, I would say.
Trying to promote the use of the tool. Talking about the tool, Google Earth is very well known for all the society as a rendering 3D representation of the Earth. You have a 3D globe superimposing satellite images and different information, so it's very used in the common tasks of the day for everybody. But Google Earth Engine is a tool beyond these capabilities. It's more complication because it's offering access to Earth observation data and processing tools. So it's interesting for researchers in particular for all the researchers in remote sensing. This is the reason of having you both here. And I would like to speak about or to talk about an explanation of a Google Earth Engine for our researchers, the capabilities of this tool.
Yeah, I mean, for me, for me, working in remote sensing is like, I feel like I'm a kind of a superhero, because kind of remote sensing provides us superpowers, right? We can see what the people can see normally, which are like pictures on a cell phone, right? RGB colors. But with remote sensing, we can see so many things, right? We can see microwaves, like aspects of vegetation, chlorophyll, chemical components, water on the surface, and so many things. So what Google Earth Engine has done, I think it's about 10 years ago, 15 years ago, or something like that, is just putting lots of data, pretty much, I will say 80-90% of the most important missions, like from ESA and NASA and so on, all the data is put together, so they host that data. But because obviously that's a huge amount of data, you need also to provide the computational resources to manage and treat and produce meaningful results. But with an easy programming language that allows to go from data processing and results in a much faster way. That's more or less how I see Google Earth Engine.
Yeah, also it's possible to add that is using internally, the application is using Google Cloud. So in that case,
For the execution.
for the execution, for the processing, pre-processing and post-processing of the products or results that we develop. And in that case, it's a platform that nowadays you can do different type of process at global scales in a question of seconds or minutes. Meanwhile, before was not possible, or required, I don't know, weeks of processing time at some point.
And it's possible to reuse pieces of code of other researchers and share your own research, your own developments through this tool, because it's also interesting to, at this moment, we are downloading models, deep learning models for remote sensing from different webs, different places. This is one place to share information, to share our algorithms, to download datasets from other people, prepare datasets, or
in the case of the data, or in the case of the normal code or scripts that we develop, is very easy, because there are different possibilities to share the code and to share the data. It's possible to share the data in individual person or in general for everybody can read at some point, which is the clicking that we need to do for share to everybody. And the code is also easy, because it's possible to get a link and then transfer that link to whoever, and that person can use or reuse the code that you developed before. Also, it's possible transfer Git repositories, because at some point at the end the platform is working a GitHub repository, so you can create a repository, develop different scripts, and then share or to read or to write in different ways. And that things are quite easy at some point. Another thing is when we are talking about algorithms or models, in that case, the application has by itself the traditional machine learning algorithms, as can be random forest or support vector machines. In that case, you cannot save the model as we can do in a local computer, but you can transfer the script that you create, and you can reproduce the results using the script. Another thing that maybe Álvaro would like to comment, it is when you are working with, for instance, TensorFlow or deep learning that require other ways to do the.
You can execute PyTorch code or TensorFlow code using Google Earth Engine.
Yeah, recently, I think it's pretty much 2-3 years ago, they offered the opportunity to host a model that you can train in their server, so something you can train in your own computers or facility, and you can put that model in the Google Cloud platform. So it's trained, and what you can do is from Google Earth Engine itself, you can call that algorithm or that deep learning model, and then you do the inference or the predictions of the model directly from Google Earth Engine. And kind of in the back end of all that, the data is transferred between your virtual machine or whatever you have in the Google Cloud Platform and Google Earth Engine, and you are not aware what's going on, but automatically it's going behind the scenes.
So if I have a trained model, I have tried the inference process with some information, a multiprocessor image, and download it from or share by Google Earth Engine.
If it is a TensorFlow model.
Exactly, yeah.
And
Yeah.
it's a PyTorch model?
It's more tricky. It's more tricky probably because TensorFlow is a Google tool.
Yeah, so I understand. I understand.
Yeah, but I have read that there are some ways kind of to adapt PyTorch models to TensorFlow, and there is like maybe workarounds to use PyTorch.
And these computing capabilities for executing the models are for free if you are using the tool, because I suppose that there is a limit.
Well, when you host the model, no. So you are using the Google Cloud Platform. The computing power or energy or resources you are using are basically you have to pay for them.
Mm-hmm.
So
it's reasonable.
Yeah.
Every time that you use the cloud, there are two ways. Google Earth Engine is connected to the cloud in order to do the process and normal scripts in your Google Earth Engine account. In that case, if you are working in academia or in science, it's free, the use. But if you work in a private company, it's another option, and in that case, you have to pay. But for us, for instance, it's for free. At the moment that you require a space in the cloud, a bucket, for instance, in order to keep your own products or in order to save some percents, you must pay for that. At the moment that you use a virtual machine, you deploy a virtual machine in Google Cloud, you require a payment in that case. The good point of Google Earth Engine in that case is that you don't need to create the virtual machines, you don't need to deploy, you don't need to know that technical specifications in order to ingest data or something like that in the cloud. Everything is mounted already, everything is prepared to work with it, and in that case you don't need to pay. You have 250 gigabytes for save your own data and your results, and you have the powerful of the cloud behind.
It's a good tool. At the end, you have to pay for computer resources everywhere. So this is a good help. And I've seen that it's relatively easy to use.
Mm-hmm.
And I would like a comment on the learning curve for using this tool. It's easy to get started for a researcher. In general, for our one of our PhD students, for example.
Mm-hmm. That's a very good question because it's not very difficult, but it's the learning curve is kind of slightly steep, but it's continuously steep in a way that it's not like you get some level and then it gets saturated and everything is easy because.
But features require
more learning. Or the deeper you go, things start getting more complicated. But the good part is it's kind of it's not a new tool. That's probably one of the best parts of it. So because of that, there is a lot of resources. There is a lot of good reference data with tutorials, code snippets, and if there are even books and you have forums. So there is also the Google Developers group in Google, so you can ask questions to the people.
I have seen it, and it's very during your sessions in the course in the school. I have seen this page is very interesting and with many solved questions. So it seems to me easy to use. Mm-hmm. It's not easy to use deep learning tools in general. So or remote sensing. Tools, so it seems relatively easy to me.
In that case, also depends what you wanted to do. I mean, if you wanted to develop a traditional classification chains, nowadays it's quite easy for the reason that Álvaro commented before. There are a lot of documentation, there are YouTube channels, and also the guides of the application. At the moment that you would like to start to develop a new algorithm or a new processing that it is not implemented by Google Earth Engine functions, in that case, the learning curve increase a lot.
That's worse. Yeah, but if I can add something that I think is very interesting, and I thought about that, a few years ago, is the fact that we in Europe, or developed countries, we have access to hypercomputing platforms and things like that because many projects, right? They have files to create these monsters, processing whatever we want. But we have to think about people who has not these resources. So even you can run Google Earth and have your results with that tablet, right? So imagine that you're in the middle of nowhere. You don't just need a little bit of networking to send the minimum information that requires to say to the Google service, you do this and that and that. And you can produce like really, really incredible results in terms of the resolution and data involved and so on. So I think kind of democratized the remote sensing of observation for the planet.
It's a very good point, because it's too fulfilling to see the results of the algorithms projected over pieces of the Earth, as you have shown during this school. I think that it's a pretty interesting tool, and I'm very delighted to have you here and to have this conversation with you. Thank you both for hanging out with us and sharing these insights. It was great having you both here. Thank you.
Thank you for inviting us. It was a pleasure.